And in this case, mine was wrong. We are talking about problem 12, page 279, problem 12. The range there is a -2 to 4. The domain is from -2 to 4, not a -4 to 2. Okay? Now, the first while, probably 10-15 minutes, let's go and take a look at some of the problems that you're working on, so you've got that. And then the last 20 minutes or so, I'm going to do L'Hopital and see how that works. Okay, anybody have a question? Yes?
Can you do number 7?
Number 7?
True that.
Okay. Now, number 7, we know it's...
Yes, we're filming. Are we supposed to have our assignment right now?
Yes, yes.
Aaron, really?
Yeah, I was actually done.
I like that, Aaron. That was cool.
You're welcome, Mr.
That's an
Chairman.
integrity move.
I agree.
You're the man for integrity.
I believe that was not an integrity move at all.
Oh, from Aaron? Absolutely.
Someone to piss
That's all I do.
Something like that.
Come on.
Everybody knew he had an assignment done. He made certain everybody else was too.
Yeah, Chanel, hand your assignment.
There's always that one
Paper,
guy.
I'm done. See this?
Sorry.
Okay. The first thing I'm going to do is check to see if this one really is a Rolls problem. That's where we ran into the problem with 12, where it wasn't. Okay? So here we go. If I put a 0 in here, what do I get out? Thank you. Good, got that. And if I put a 1 in here, what do I get out?
0.
Okay.
0.
Okay. Any questions about that? Now what happens here, we have a function that we're going to, let's see, what I'm going to go from 0 to 1, and it's a parabola that opens up. So I think we probably have a parabola that looks something like this.
No.
Now all we're doing is finding out that we have, these two have the same value.
It's a third degree equation.
You are right. So we'll go this way. Thank you. Yes. Okay.
Brilliant.
Okay. Now, Brandon, that was very helpful to do the third degree, because what's going to happen is we're going to get 3 answers out of here, or 2 answers out of here just instead of 1. Okay. Now, Rolle's theorem says because of this, someplace in this interval, we're going to have f prime of some letter c is going to be equal to what? And everybody said 0.
0.
Okay? So here I go to the derivative. F prime at x equals, and this happens to be x cubed plus minus x squared plus 1. Right? This here is x squared plus 2x minus 2x plus 1. So this should be a 2 here. See that? And then just multiply by x. It's easier to find the derivative that way. Okay? Okay, so what's the derivative?
3x squared minus 4x.
Oh, this should be an x2, right?
Plus 1.
Plus 1. Okay? You got that far. Okay. Now, that says, oh, I like that. That's minus b, so it's 4 plus or minus the square root of 16 minus plus, no, do I have the right letter here? Yeah, I do. So it's going to be plus 12 all over 6.
I got that far.
Oh, you got that far too? Okay, now I should find out what these numbers are. And your calculator turned out, Jeff, do you have these numbers?
I handed it in already.
Okay. Anybody have those quickly?
I did it in my calculator.
Yeah, that's good.
1/3.
Oh, that's 1/3 and?
I just got 1/3. 1/3 is the only answer.
I know, but I wanted the other one
It's
too.
like one.
Oh, then this is factorable. Oh, I didn't think it was. Okay, so you have these two numbers. This happens to be an endpoint, so we can't use it. So it has to be thrown away. Oh, shoot, I was thinking this was the one that had the quadratic formula.
So you can just factor it. You don't have to use the quadratic.
No, you can just factor it. Yeah. Yeah, you saw I got caught on it too.
Oh.
Okay. Next
Did
question.
you just graph it and find
Pardon?
I just graphed it and found the point.
That's just checking the answer. Totally unacceptable. Okay? Yes.
You said you did number 9. Okay.
Pardon?
You said you did number 9.
Okay, number 9. Okay. Now, Brianna, I like that business of checking it because that is so helpful. Okay? Now, look at 9 in terms of this, and please see how the trig is. I'm going to have my blue sheet with me for this problem. I don't have the blue sheet, but I don't need it. You probably do. So we have this. F at x equals cosine 4x, and we're in this interval of 8 pi over 8 and 3 pi over 8, I believe. Okay? Now, if you put these two in, you'll get the zeros that we need. Okay? So I'm not going to go there at this point. So I'm going to take the first derivative of this, and I'm going to get what? Right?
Negative.
Negative.
Negative sign?
Negative.
Okay?
Why is there 4? Oh.
Because of the inside chain rule.
Okay, yeah.
Okay? Now this is equal to 0. Or we have this. The sine of 4x equals 0. Questions on that? Okay, now at this point, you probably all should be watching. How do you solve this? We have done that. Okay? That is changing these two positions. The sine inverse of 0 equals 4x.
Okay, where did the other 4 go when you dropped it down?
I divided both sides by -4, and -4 times divided 0 into that many is still 0.
Good.
Okay? Now, okay, in this case, where is the sine equal to 0? This is what this is saying. Your calculator will give you a nice big 0, right? Which is not very helpful. Okay? Now the sine is going to be 0 here, here, and here. And I don't know if I have to go further, but I know that. So the sine is going to be there at 0, at pi, and at 2 pi. Okay? And so I'll just take these. First one I'll go is pi equals 4x, so x equals pi over 4. Okay, is that in between here? Yes, it is in between here. Now the next one I'll put 2 pi equals 4 pi, and so, oopsie, 4x, and so I get pi over 2 equals x. Okay? Now, is that a solution in here?
Yes.
I don't think so. It's too big.
Not so fast.
Because, see, this is 4 pi over 8. And that's outside of the interval. Okay? But this one is right in that interval. Are you with me? Going from here? I don't know how your mind works in terms of what you have done to model it. You might have modeled it like this too, on that kind of a thing. Okay? Now this number here does not come out of the calculator. Listen here. You have to know inverses. Okay? Now, next question. Anybody?
12.
Okay, when you do 12, you'll find you cannot get a derivative. It's not differentiable. Okay? So that's the deal with that one. Okay, I would like to do one with the next group. Yes?
Yeah, I was going to ask if you could do a mean value one.
18.
My 18.
Because that's assigned up to there, DeVries is trying to get it cheap.
No, it's just a hard one.
Yeah.
It is hard.
It looked challenging.
18.
I tried.
Can you do 18, please?
Can I pay you?
Oh,
I tried.
we are paying you.
Okay, now, I would much prefer not to do that one, because it is so nice.
Do 18, please.
We do have a break coming, so we'll do 18s for DeVries' sake. Okay, now I do have to check my book to see if it is correct, and that's 1 and E. That's my interval. Okay, when I put 1 in here,
ln of 2.
that's ln of 2. Okay? Oh no, I don't have to do what I was saying. Okay, we all watch this a minute. I need to find out, and this function is going to go like this. See that? And so I'm going to run it from here to a point over here, which is about 2.7. I'm looking at this interval, and now I'm going to have a point over here like this, and I'm going to be looking at, oopsie, I was going one, yeah. So I have this thing, and I'm looking for this line right here, okay? That's slope. Okay, here we go. Now, this point is what? When I put a 1 in here, I get a 2.
ln of 2.
Okay, so we go 1 comma ln of 2, and the other one is what? When I put an E in here.
2. Does it?
So I get E comma 2.
1.69.
Okay, how does he get 2? Okay, we go ln of 2 plus the ln of E. So I don't think, DeVries, this is going to be a 2.
I thought the ln of E.
1.69.
I did that wrong.
Okay, I think this should be ln of
It's 1.69.
1.69. Just a second, let me just get back here a minute. When I put a 1 in here, I get this 2. When I put an E in here, I get, I don't get what I said, I get ln of 2 plus 1.
ln of 5.4.
I'm not interested in that though, I want this.
How do you get ln of 2?
Pardon?
Well, because ln of E is 1.
Yes, it is.
Okay, just a second. Here's my function.
Yep.
Okay, and I've got to put these 2 points in here.
Mm-hmm.
This point is 1 over right here,
Yep, I get that.
and I don't have it drawn right. And the other one is over E, and how high do I, so I put an E here. So that's ln of 2E. Okay, and so here is ln of 2, oopsie, ln of 2E, which is equal to ln of 2 plus ln of E.
Can you focus it? Okay, I get it.
Okay,
Yep.
somebody focuses for me while I'm going. Okay,
I get it.
and okay, so we got that done. Now, the next thing we have to do is to get our slope. And the slope is going to be what? We're going to go, the denominator is going to be E minus 1.
Yep.
Okay, and the numerator is going to be ln of 2 plus 1 minus ln of 2, which simplifies into 1 over E minus 1.
No, that's
Okay?
y minus y.
Questions?
Yeah, so how'd you get that numerator there then?
The numerator,
Yeah.
it's this minus this. This is delta y all over delta x. Oopsie. These are y's and these are x's. Slope.
Oh, so wait, so you're saying, so the 1 is the first x there on that point on the graph, supposedly?
Yeah, I want the slope of this line.
Yeah, and so, okay, you're using normal slope, and then the y's, you found those using, just plugging them into that equation.
That's right. Okay? Yes?
Do we need to take the derivative?
Oh, okay, we're ready. Now we're going to take the derivative. Now the first derivative is going to be equal to what? It has to be equal to this. The one I'm looking for. Because I'm looking for a special x, which we call c, in this interval. Okay? And it has to equal 1 over e minus 1. And what's the derivative of this?
1 over 2x. Yeah. No, times 2. It's 2 over 2x.
You with me?
1 over x.
Now, we have looked at that before, and it's a little tricky. Anybody have a question where that 2 comes from?
Yeah.
Chain rule?
Both of them come from.
The chain rule says this is equal to 1 over what we have here, and then we have to find the derivative of that, which is a 2. Okay? So now what is x equal to? X is equal to e minus 1.
What? Okay.
This is so confusing.
I don't get it.
So what is that?
Okay, just a second. Grant is struggling back there with following it, and there's others that have it too. Let's go back, and I'm going to redo some of this a minute, and I'll get back here in a minute. And because the last step I got here is not difficult, but I want to make certain you're with me. We've got to have these 2 points, this point and this point. And the first point is going to be 1 over, and we said it was going to be ln of 2. And this point up here is going to be e comma ln of 2 plus 1.
Because you plugged in the e for that second.
Yes. Yes, to get this, see when I put an e here, that's what you get. Okay? Now I'm going to go with the slope. Are you with me with the slope?
Yeah.
Okay? And so that gives me this, you're over here.
Yeah, I'm right there.
Okay, Brianna, you made a comment too. Are you with me at this far?
Yeah?
Okay, very good. Now, Tanner said a while ago, well, we have to take the first derivative because the mean value theorem says there is going to be a line here like this that's parallel to this one. Okay? Now, okay. This is taking me a little bit too much time. Okay, now, so we had to find a derivative like this. Are you with me? Which is going to be 1 over 2x times 2. Because it's 1 over this, and then you have the chain rule of the inside, so this is going to be 1 over x. Now remember, we did this kind of problem before, and now we have it reappearing? Okay, and that has to equal 1 over e minus 1. Well, take the reciprocal of both, and x equals e minus 1. Okay, now I have to think here a moment. Is this point in between here? And the answer is yes, because this is 2.7, so it's 1.7, so it's nicely in between those 2 values. So it happens at this thing right here. Okay?
All right.
Now, since we've done this one, I would like to get to something else in a minute, but let's go to a problem that I've assigned up there, since DeVries is on that kick anyway. Will you go to problem 29? 29, read the problem. Read it. This is one that's almost in every calculus book because it's got a little humor in it. Make me sad.
What?
Okay. Notice the officer is a woman. Did you get that? And some turkey goes, he takes off, and then he goes, how far?
30.
30 miles. And he does it in how much time?
28.
minutes.
Okay, with that in mind, what was his average speed?
Faster than 60 miles.
Oh, I didn't ask that. I asked what it was. Not a faster one. I would like to know how fast. You can calculate that a minute. Oh, it's just fast.
Fine.
30.
Very nice.
I know.
Do you?
Almost. Break the calculator out. Oh, because he went
It's a good thing.
30 miles. in
64
28
miles per
minutes.
hour.
Ooh, is it that fast? I didn't think it was that fast. Is it
I'd
64?
pull you over for that.
56.
Well, it is a woman, so.
Okay, now.
Okay.
Is it what? 64. 64.
64.
Okay, now, what does that say? That says,
They were speeding.
okay,
Make sure you don't speed by 4 miles per hour.
no. Okay, so here you get there, and
Speed trap.
the guy gets stopped, it's a guy this time, and she pulls him in and says, see there, you were going 60 miles an hour, and I'm gonna write you a ticket. He says, you cannot do that to me.
Terrible.
Oh, listen, you can't do that to me because I was going 60 and that proves it. And no, she says, I learned in school the mean value theorem. And the mean value theorem tells me you are going faster than that. Well, he says, I will take it to court. And I will prove to you, because it says there, in fact, I take my iPhone out and shoot that radar and it says 60 miles an hour. An officer, the officer's clock said that. And then the officer, this woman says, that's okay, I know the judge. And he's also taking calculus. You're doomed, yes. Pardon? No, 60 miles an hour. Okay, thank you. Okay, now, that's the kind of stuff, and I remember sitting in a university in Chicago doing an advanced calc thing. And there it had this kind of little problem in it, and it dealt with an officer and a little video. So if you find any little videos or stuff like this, YouTube, there might be some, and I don't know the current ones. So if you find something interesting, please share it. Yes?
So isn't that just algebra?
No, it's not quite algebra.
Okay.
So
Kind of, but not quite. Okay, now this is his average speed. Okay,
why did
now,
you conclude that?
pardon?
So how
But it
do
should
you,
have taken him 30 minutes to get there instead of 20 minutes.
will you get stuck all you have to say for the answer?
Yeah.
Okay, because you're going from 0 to that place,
Yeah.
and you're averaging 64 miles an hour.
Yeah.
Okay, if you're averaging it, you're going to have to be going over 60 to average it, because you're going from 0 to 60. Okay, now the next problem is a little twist on it. Okay, and then the next one is a slight twist again. They're both very easy problems. Okay? Okay, now, hopefully those will be somewhat entertaining. Now, the next thing I want to do is this. I will do the theory of this one later, but I'm going to do a law which is L'Hopital, and since I don't have a lot of time, we're going to keep moving and a number of applications. And one is this. What is the limit of the sine of x over x as x approaches?
1.
Okay, now, I'm going to show you how to get that answer very quickly today. Let me do another one, and that's this. What is the limit as h approaches 0 of f of x? Is it minus f at h? Is that the way we do it? All over h? Yeah, it's both this way, plus h here like this. Okay? What is that equal to? That's going to be equal to f prime of something like this. That's a derivative. Or we'll just do an x here like this. Okay, now, notice what we have here. A couple of things. When I plug this in here, that's 0 over 0. Okay? Indeterminate form is what we have to have. And only ones we're going to do today are those that are 0 over 0.
Should we know?
Now notice this. What's my denominator? 0. Okay? And this is 0 over 0 too, isn't it? Because h is 0. So this is f of x. This is supposed to be an x, isn't it? Okay? I think.
Yeah.
Okay. Now, so what we have in terms of L'Hopital's rule is this. Now you have to be careful how this is written. It's a limit of f at x as, no, let's do it this over g at x, like this. As x approaches 0 is equal to the limit as x approaches 0 of f prime at x over g prime of x. That is a huge jump.
Whoa.
Instead of doing this function, I can do the derivative function. Okay? Now, with that in mind, now first off, we'll do much more of the detail. We'll just work a few problems today to show that these are kind of fun. At least easier than some of the other stuff we have. We have to have it in the indeterminate form. Okay? So, now, look at this. This gives me the limit as x approaches 0 of, what is the derivative of this?
Cosine x.
What's the bottom?
1.
Okay, what's the, if x goes to 0, what is this?
1.
1 over 1 is 1. See?
Whoa.
Bingo. Got it?
Question.
Yep.
So all you do is just take the derivative of it?
Yes.
So how do you get equals 1, did you just say?
Well, put a 0 in here. Cosine of 0 is
Ah,
1. Okay? Now, be careful, this isn't the quotient rule. You got it?
Yeah.
We'll review that again. This is not a quotient rule. It's just straightforward. Okay, now, let's do a few more. I have some of my paper here. How about this one? We're going to go to this one next. How about the limit as x approaches 2, and I do have it on my computer too if I wanted to look at it a minute, minus 4. Okay, is that 0 over 0?
Yes.
Sure.
No. Oh.
What'd you ask?
Maybe.
Let's take derivative.
Well, you need to find the derivative.
No, no, I don't have to do that first. I first have to see that it's in indeterminate form.
Yeah,
Correct. Yeah, it is.
Okay, I've got a disaster. Hey guys, got it? It has to be this disaster. Okay, now I'm going to take the derivative of that, and I'm going to go there, and that turns out to be
4 over 2.
Over 2.
and so that's equal to 2.
Question.
Yes.
What if you have like x minus numbers? Does that just mean you solve for it to equal 0 again? Like you have been doing?
I didn't follow that.
Like if you get like x minus 2 on top and x minus 1 on the bottom, do you like solve them each for equaling to 0? Or how are we supposed to do that? Because they're not always going to come out to just numbers like that, are they? If you have a second degree, you're going to have a variable.
Okay, so, DeVries is doing this one. This brings me to the next part. Let's see. Let's do the limit, oh, I don't know if I like this one, as x approaches 2 of x cubed minus 3x squared plus 4 all over x to the 4th minus 4 x cubed plus 7x squared minus 12x plus okay, now,
To infinity and.
okay, we're going to start by just assuming that it's 0 over 0. Okay? Now, I'm going to take the first derivative, and I'm still going to go to 2.
It is 0 over 0.
Yep.
Okay? So this gives me
3x squared minus 6x.
Over 4x cubed.
X squared plus 14x.
Minus 12.
12.
okay, now we got to check that one out. You got to check it out. And again, because of time, I'm not going to go there.
0.
Okay? Still doesn't help.
0 to 2.
Okay? Now, the main one is does the denominator go to 0?
What do you? Okay.
32.
Can we just not have an assignment on 4.7 over break? Please?
Okay, now the next one.
Yeah, it's over 0.
Okay, now, the next thing I'm going to do is take it again. I did it once, I'm going to do it again.
So if it doesn't work the first time, you take it again?
Yes, and provided again that it's 0 over 0.
Oh,
Okay, okay, so this gives me,
6x minus 6 over 12x squared minus 12.
I got you.
that one works.
Trevor. I'm in La La Land.
12x or 24x plus 14.
okay?
Keep taking the derivative because you're able to exit.
Mm-hmm.
Oh, okay.
All right.
Okay, so, hey, I would like to do a few more instead of just, well, I guess I could do this one more time. Well, okay, it's important. Does the bottom still equal 0?
Sure.
Okay.
48.
Okay,
No.
now guys, If it doesn't equal zero, you're done.
Then you're done.
Okay?
doesn't equal
So it's important, dump it in here.
6/20.
Okay? So, and it does equal 0 at this point. So do it one more time.
No, it doesn't.
How does it?
Doesn't it equal 0?
No.
It's 48 minus 48 plus 14.
It equals 14, guys.
So this is 14,
Over 6 over 14.
6 over 14. So that's my answer. Okay?
I like this,
So that's your answer. And once it doesn't equal 0,
Then
you can
you
get
are
it.
home free. Like
Okay.
storing the
Okay,
points.
now
Wow.
listen carefully. The question came out, we only have trouble here as long as there's zeros in the bottom.
cool.
As soon as the zero is out of there, we can figure out its value. Okay? Now,
So you have to get 0 out of 0 every time.
Okay, who's throwing Swedish fish? I want one.
hey guys, we have far too much done. Brianna, that's not the first time today.
Yeah.
Here we go. Let's try this one. And then I'd like to work with one that has a sine and a cosine in it, that kind of stuff. X squared. Now, does that equal 0 over 0?
You bet it does.
Yeah, 1 over 1 is quite.
No.
This is 1, and minus 1 is 0, that is 0.
0 over 0.
0, 0. Okay,
Zero.
now, that equals 0 over 0?
Yeah.
Okay, then we'll do it one more time. And this, what gives me in the bottom?
Oh, you got 1/2.
Half.
Woo!
Half.
And we can end it.
Yeah.
Yes. Yes, many times.
Oh, really?
Yes.
So then what do you do then?
Go back to chapter 2 in the book. Yes.
Because like if you won't you get like at least 1 in the bottom?
Not necessarily. Not necessarily.
Well, like if it was just a plain number in the bottom.
Is this pretty much all that this chapter, this section is?
This whole section is that way, and I had another one that I wanted to do.
Can you do like number 22?
I don't really think you want me to do that one.
It's gorgeous.
Is it easy?
45 degrees.
Okay.
Which one?
Is it
Okay.
easy or something?
Okay. Let's see. I wanted to do one to give you a little experience with some more trait stuff.
15?
This one. We're not quite here, but I'd spend a little time with this one. I've got enough time on the. Okay, now this one here is a little different, and we'll talk about it on Monday or Tuesday. And this is what we have. Now, listen to what I have to say, and then follow along, because I would like you to be able to do this. Okay, this is just a plain X. Okay, now,
What number is this?
this is one not in the book. Okay, now, what I have here is not 0 over 0, but we could also have this indeterminate form. Okay?
Oh, dear.
Okay, now,
Oh dear.
we got a lot of extra comments. When I put pi halves in here, this number becomes and see, I'm going in the negative side. Okay? Now, that means I have this is my tangent curve, like this. And this is pi halves, and I'm on the negative side of it. I'm on this side of it. So this is going to be infinity. Infinity plus 1 is?
Infinity.
Okay, and my secant also runs here without doing a lot of things. I'm on this side, and this is also an asymptote here, and this is my secant. It goes this way.
Nice.
Okay? And now on this side, and that's infinity.
Yep.
So I'm infinity over infinity. Okay, so maybe you need your blue sheet to do some of this stuff, or just have it straight. Now, yes?
So the infinity over infinity ones are only if you have like tangent sign or that kind of stuff?
No.
Is that another one? Like
Yes, that's, okay, it's like 0 over 0. In fact, okay, now,
you can use both.
Pardon?
You can use both.
Yeah, well, you can use both, but you won't use them both in the same problem. Okay, now Aaron, you notice what Aaron said? He wanted to know about infinity over infinity. What happens when we studied about end behavior of polynomial functions, or rational functions? We talked about end behavior. Do they go up, down, or is there a horizontal asymptote? This will give you horizontal asymptotes, but I won't have time to give you one of those today. I will repeat it and do it on next time. But now watch what happens here. We've got infinity over infinity, and this is kind of cool. But it is also, you really have to know your stuff. And this is 2 on the negative side. What's the derivative of that? Okay. What's the derivative of this? Secant x tangent x. Oopsie. See that?
Yep.
Now this one cancels with this one up here. Are you with me? Okay, now this becomes 1 over the cosine, right? And this denominator over here, now that got dumped down here, and this is going to be sine over cosine, so I'm going to put it over here, right?
Oh, yeah.
Okay, now this cancels with this. Okay, so this turns out to be, what I'm looking at now is just x of pi halves, just on this side, of 1 over the sine of x.
And what is that?
Oh, you want to do it that way. I can't think there. But I do know this one. I just have to put pi halves in for okay, what is the, okay, now look at this. Here we go. Here's the sine curve, like this. This is pi.
Pi halves.
Pi halves is going to be equal to what?
1.
So this is equal to 1.
Whoa.
Yes?
Me? What do you mean by the little minus on the 2?
Okay, guys, I understand that. We can't hit pi halves because it's undefined.
Oh, so it's on the left.
So I'm on the left side.
Okay.
Okay?
Just like the window.
Okay? Now, let's, a question. I know you are eager, but I'm going to keep you until the bell rings here. Yes, I am. Because some of you guys were wandering way down the hall yesterday. I was thinking of giving you an extra minute or two because of that. I decided not to, though. Aaron's question. Aaron's question is this. The limit, as x approaches infinity, of 2x squared over 3x squared plus 1 up here plus 2 down here. What is it going to equal?
Infinity over infinity.
Infinity. Okay, so now you know this answer to start with. What is the answer?
1.
1.
No.
0.
No.
2/3.
Very good, Brianna. We take these two because these two are the same. Okay, but we didn't know that. So here we're going to find it. What happens to end behavior? Oh, this is great. Bell rings, you cannot leave. What does this turn into?
6.
4x
Oh, yeah. 4.
over 6x.
Okay, can we do this one? Infinity over infinity.
Yeah, we can.
Okay, I'm going way too fast.
4 over 6. 4
Oh,
over 6.
4 over 6.
This is a 4.
4 over 6.
And this is
6.
Are you sure?
Yes.
So this is
Let's get out of here.
Two.